Cool. Let's get crack-a-lacking. So what is this new unit all about? It's mainly about triangles and solving for unknown sides and unknown angles in triangles. So when I think of triangles, I'll just draw a couple here. They're not perfect, but let me draw a couple here. And then the triangle that looks like it's bending over backwards. So some important words that you kind of need to know about, or vocabulary, is we call this an acute triangle or an acute angle triangle. We would call this a right triangle, and we would call this type of triangle an obtuse triangle or an obtuse angle triangle. Now, the reason we call it that is an obtuse angle triangle has one angle that's greater than 90. And then with the acute angle triangle, all the angles are less than 90. And then a right angle triangle, we've got a 90-degree angle. Okay, so that's the first bit of terminology. When we name triangles, we normally name the vertices or the corners using the uppercase letters of the alphabet. So I could talk about triangle ABC or DEF. What comes after F? A, B, C, D, E, F, G, H, and I. Now, we use the big letters for the corners. What do we use the little letters for in geometry and triangles? What do we use the little letters for? The sides, exactly. So when we do geometry, it's important to remember that we can refer to sides by naming the two vertices like BC, or we could use a side and we could call it A if it's opposite the big A. Or we could say that this is B or this is C. Okay, so that's helpful to know. Or another example would be like this could be called D, E, and F. If you just, Kia, if you could just put on mute all, because I think there is a little bit of audio thing that's blending through in the lesson. Okay, then what else is important? When we talk about triangles, the biggest side is always opposite the biggest angle. So, okay, I'm just going to hit mute all here, I think. Mute all. Okay, cool. All right. So if we look at the biggest angle, let's look at the obtuse angle triangle. We would say that the biggest angle is this one over here, it's H. And so the biggest side is opposite the biggest angle. And then what do we think is the next, what's the smallest angle here? I think the smallest angle would be I, let's say up here. And so one of the ways of distinguishing between the different angles and sides, let's make this an open one, is to show different symbols for the angles and different symbols for the sides. And if they're different, it shows that, that they're not the same value. And so often with triangles, we use the stripes to indicate the different sizes of the sides. If we have an acute angle triangle that's equilateral, you would often see something like that. Okay, that's the basic terminology. Give me a thumbs up if you're okay and familiar with those ideas. Give me a thumbs down if that sounds new to you. That's like what I would call triangle basics. Okay, now the other things, as we go about solving triangles, we normally solve for sides, angles, or area. We give you some information. You have to use facts about triangles to figure out the rest. So we're just going to remember some facts about triangles to get going today. I want you to solve for X in triangles C and triangle D. So what is the value of X in each of these two triangles? I give you some information. You have to find me the missing angle. Off we go. And then if somebody's feeling like they got the answer, they can pop it in the chat, or they can raise their hand to share their wisdom with us. Okay, so the first answer that is coming through for C is 44 degrees. I want to ask, how do we know X is 44? Who wants to, is it magic? Did it come to you in a vision? Or is there some logic that you are relying on to tell you how to work out this X? I suspect you've used the fact that all triangles equal something. No matter what triangle you have, a triangle will always add up to 180, and that's what Empor is put there. So you would go 180 minus 80 minus 55, and then I don't think it's going to be 44. It feels to me like it should be something different. It should be 45. Yeah, 45. Because you go 180 minus the 80 minus the 55. And the reason we actually give for this is sum of angles in a triangle. We know that a triangle will always add up to 180. And so that's the first triangle fact that you need to keep in mind. Okay, what about finding X for D? Let's find that. What's X going to be in that case? I'm going to use a very similar idea, except this is 90. That's the symbol for 90. So we go 3x plus 90 plus 2x plus 10 must equal 180. And what we do in mathematics is whenever we make a deduction or we make a claim, we generally have to say why we think that's true. And the reason I think this is true is I know that the sum of angles in a triangle will always add up to 180. And now I can make the statement, this is equal to 180. And then I'm going to use some algebra to get me down to that. So what is my X going to be equal to? Because I added the 3x and the 2x to give me a 5x. And I added the 90 and the 10 to get 100. What's my final X value going to be? I think it's just going to be 80 divided by 5, which is going to be 16. Yeah. And so now that I know what X is, if I wanted to know what this corner here was, this angle over here would just be 3 times 16, which is 48. So this angle would be 48. So often when we're solving triangle geometry problems, sometimes we have variables inside the triangles, and then we have to figure out the relationship between the variable and the actual angle in the triangle. And normally it's just a substitution back into the angle. Okay. Cool. Thumbs up if you're feeling good. Thumbs down if you're feeling a bit behind. Just want to get that feedback from the group. Okay. Okay, let us make things a wee bit more exciting. I want you to use some other things that you know about triangles to help you find, in fact, let's not do A. A is a bit easy. Let's do this one over here. I want you to find me the value of Y and the value of X using the information that you're given. And all you're given are these two whisker things and one angle. And you have to tell me what X is and what Y is. So these whiskers mean that these are equal sides. And if they're equal sides, the angles opposite these equal sides must be equal. And so we would say angles opposite equal sides, and that's going to be 44. What's y going to be? Well, this is a triangle, and we know all triangles add up to 180. So if I just take away what's already in the triangle from 180, I should then be able to get my answer. Put my reason below. So what's my y value going to be? 180 minus 44 minus 44. I should indeed get 92 degrees. So when you're solving a triangle, know, the little facts about triangles that have to kind of be in your head and ready to go. Also, let's do another one. Let's do something a little bit more interesting. Let's solve for X, Y, and Z. So in this question, I want you to find what X is, what Y is, and what Z is. And this is just going back to grade 9 and 10, just to make sure you've got your triangle basics with you. And some other line geometry. So Y, I can see that students are saying that X is 62. So angles on a straight line, yep. Fantastic. What about Y and Z? What are those going to be? Well, same thing as last time. These are equal sides. And so that one must be the same as that one. So angles opposite equal sides. And then the last one for Z is just going to be 180 minus those two. So what are we going to get for that? So for Tekel, what I did was, in order to get X, I said that the angles on a straight line add up to 180. And so I didn't actually show the working for this, but I went 180 minus 118, and I got 62. And then because these two sides are equal, the angles opposite them will be equal. And so that's why Y must be 62. And then the last thing I did was I said, well, I must just go 180 minus 62 to get the Z. And that's using the fact that the sum of the triangles, some of the angles in a triangle are always 180. So what do we get for Z? It seems like we would get 56. Yeah, 56. Okay, cool. So that is the first bit of like what we need to know about triangles to kind of get going in this topic. Let's have a look at something else from your past, a blast from the past here. Let me go through all these. We don't need these. I want to talk to you about, here is a right angle triangle, and you may have heard of this theorem called Pythagoras' theorem. Which of these four options is the correct description of Pythagoras' theorem? So it's all good and well to know that a squared and b squared and c squared are involved. But what are the important markers that we need for this one? I'll give you one hint. The opposite, the hypotenuse, or the right angle, is the hypotenuse. We would call that H. And that is the one that is normally by itself. So when you write these squares, you would say c squared is equal to a squared plus b squared. So remember, the biggest angle will always be opposite the biggest side. So this thing here is going to be the thing by itself, and that's equal to the other two sides squared and added together. So that's an important idea. You need to have fully mastered Pythagoras' theorem in order to do well in this topic. So let's just check that you know how to use it properly. I want you to find me the value of x in this right angle triangle, and I want you to find me the value of x in this right angle triangle. And the hint that I will give you is that look for the hypotenuse. That will help you. Okay, so what do we have? It seems like for the first one, we have x is 6 centimeters. But what about the second one? What's that going to be? Well, the 7 is the hypotenuse here. So it's opposite the right angle. So we go 7 squared is equal to 1 squared plus x squared by Pythag. But now the problem is we have to get this x squared by itself. Or we want to get x actually is what we want. So we have to do some rearranging. And what we do is really we just bring that across. And then to get this from x squared to x, maybe I should put this step in. We can just square root both sides. And then we will get whatever the answer to this is. So 7 squared minus 1 squared. You might have to bring out your calculator here. I'm guessing it's like 6 point something, 6.93 millimeters. And that again makes sense because it couldn't be 7 because 7 is going to be the longest side opposite the biggest angle. So I'm going quite quickly because we're looking over stuff from grade 9 and 10. But again, I don't. Sometimes people have missed out lessons and I don't want to go too fast. So again, just a quick check, thumbs up if you're feeling okay with the pace, thumbs down if you're feeling a bit like, slow down, Mr. Teacher Man. Okay, so remember, anytime if you want to ask a question, you can, guys. That's the wonderful thing about being online. There is built-in flexibility, but I'm not going to, I think you are looking comfortable with that. Okay, now, next. I want you to calculate. So instead of finding a side and finding an angle, now you have to find me the area of this triangle. Now, maybe somebody can give us a hint. Rufen says it is an up a notch now. So it's all right. We've got friends who will help us. When we talk about the area of a triangle, what do we normally need to have in our toolkits? What am I looking for? What do you remember? So Kat has said a half base times height. I think Adila has confirmed the same thing. So I want to ask you a bit more. What am I looking for when I talk about the base and the height? It's the perpendicular height. So actually the base and height are going to have to meet at the right angle. And so the problem you have in this question is you don't know what the red side is. Because if you knew what the red side is, this question would be easier, would be easy. But maybe somebody else will spot something that will unlock this. What do we think? What do we think could be done to find the red side? Yeah, Pythagoras, of course. You're given two sides and you want the third side. You're given a right angle, so you got all the preconditions. So you kind of, if we make this x, we make that x, you could say 25 squared equals 7 squared plus x squared using Pythagoras' theorem. Now work out for me what x is and see if that can help you work out the area and choose the correct option for this question. So Tebogo has said x is equal to 24. And I agree with you, Tebogo. So if x is equal to 24, now the question is, how do we get the area of this shape, or this triangle? And we say a half times the base times the height. I think it's just going to be that calculation, which then gives me what? I guess it's going to give me 12 times 7, which is 84. Where to? Can we use tan to find the height? You could. Yes, you could use. I'm going to get to that later in the lesson. We're just kind of getting going. But you could use tan to find the height. Absolutely. So for Tejo, the reason it can't be the height is the height and the base have to be the two legs of the right angle triangle. And so that the 25 couldn't be used because it's not the height of the triangle. The height and the base are always at the perpendicular height of the triangle. Yeah. Okay, so the correct answer would be A. Yeah, and Tova and Owami agree. Okay, so now before we move on, the second half of the lesson is going to go more into the trigonometry side of things. But just to kind of round up this first part, this was all just getting familiar with the language of triangles and getting familiar with the basic facts of triangles that you need to master. And then from that level, we'll build some more. Okay, but so important, the reason we could use tan is that tan would be, okay, I see your question. Okay, if you knew which one was, you wouldn't be able to. So Paul, you're actually correct. If you had an angle that this was like 17, if you had an angle and a right angle triangle, then you could use trigonometry. But because I didn't actually look properly, because there's no other angle other than 90, you're quite correct. You're quite correct. So you wouldn't be able to use it in this case. Okay, time for a break. Let us all stand up on our feet and let us take a moment to unwind our brains. So here, you can join us in our exercise thing if you feel like it. Otherwise, in future, you can't see your videos not on. So what I want to do is I want us to start by just shaking out a bit. So just shake out your arms, shake out your legs, just loosen up your body because you've been sitting for half an hour now. And let's start by just rolling our shoulders back. So 1, 3, 4, 5. And then let's roll our shoulders forward. 1, 2, 4, 5. Then let's do a bit of rotation, a light rotation from side to side. And then let's go a bit further after a while. Oh, I can hear clicking. Okay, and then let us do a shoulder stretch. Okay. The other side. And then let's do a tricep stretch like this. And the other side. Okay. Then shake it out again. Shake out the arms, shake out the legs. Then I want to do something new today. And the way this works is you breathe in, breathe out, snap one hand, snap the other hand, clap. Let's just do 3 of those. Okay. That was just a new, apparently that's meant to help calm your nervous system. And then let's do a heart rate raising activity. Let's just do 15 jumping jacks. So we'll start in 3, 2, 1, and let's go. 2, 4, 5, 6, 10, 11, 12, 13, 14, and 15. And sit back down. Okay. And today's little brain break. Tell me what, I don't think we've done this one before. Have we done this one before? Tell me what. No Mass 24, not today for Tickle, but I'll bring it back in future. I just wanted to do something different for a while. So indeed, the apples are 3. You are quite correct. But what I want to know is what is a peach plus an apple times 11? That's the real key question for tonight. What is 11 times 11 times 11? I guess 11 must be 2 because, yeah, that makes sense to me. Now, what is a peach going to be? Or orange? So if that's 6, 6 times something gives me 96. Or we could say 96 divided by 6 if you wanted to be sneaky. And that would be 16. And so this is going to be 4. So what's my final answer going to be? Using BODMAS. BODMAS says 3 times 2 is 6. And then 6 plus 4 is 10. Yes, Ongani, Emmanuel, Refense, you are spot on. Tebogo, Ndile, Kunile, Ntukozo, you are winning at life. Well done. And Owami, well done too. Okay, cool. I hope you enjoyed the break. Let me know in the chat if you're feeling a little bit like you've had a bit of a break and that you are ready to rock and roll for the second part of the lesson. So what are we going to do now? So these questions are a little bit different. In this question, it says, what is the length of side A? But the problem is we don't have 2 sides to use Pythagoras. You can use Pythagoras if you have 2 sides. What we've got is a right angle and another angle and the length of one side. And so we need to use a different toolkit called trigonometry to help us solve this triangle. And what's going to become quite important in this part is to know the names of the sides. So if you're given a right angle, we talk about big H being the hypotenuse. If we're given an angle that is not right angle in a triangle, that reference angle, the side opposite that is called the opposite, and then the remaining side we just refer to with big A or adjacent. And so in order to solve for this unknown side over here, what color should I use? Let's use yellow. In order to solve for this, what I'm going to do is I'm going to use trigonometry from grade 10. And I'm going to use the acronym SOHCAHTOA to help me. And what SOHCAHTOA says is it gives me the names of the ratios that are stored in my calculator. So I'm given 16, and I really want this side over here. Or another way of saying it, some teachers say what I want, which is going to be little a, over what I know, which is 16. So what I want, which is little a over 16, which is what I know. Which trig ratio is going to be the same as a over 16? Well, it's the trig ratio that involves the a and the h. Which trig ratio involves the a and the h? It's going to be cos. Okay, but it's not just cos, it's cos of the reference angle, and so it's going to be the cos of 31. So we can use the fact that we have trig ratio stored in our calculator. So we know there's a value for the cos of 31. We'll get it out. And we know that a of 16 must be cos of 31. So what is the value of a going to be? Well, the value of a is just going to be the cos of 31 times by 16. Because we're just going to bring that 16 from being a division to a multiplication. So which of the four options is going to be correct? That's what I want to know from you guys. Which of these four is going to be correct? So I'm taking out my calculator and I'm getting 16 times the cos of 31, which is 13.71, which gives me A. So the length of the unknown side is going to be 13.7 over there. Cool. So look at all the tools you have for finding unknown sides. So let's do one by yourself. You're given this question. I want you to find me the length of the unknown side over here using your knowledge of trigonometry from grade 10, where you use the acronym SOHCAHTOA to identify the correct trig ratio. And just to point out, trig in grade 10 only involved right angle triangles, right? That's all you had. You had right angle triangles and you had to apply the trig ratios to find unknown sides and unknown angles. So when I put that in my calculator, I get 9.7, which corresponds to C. Yeah. Okay. So we can use trigonometry to help us find unknown sides in right angle triangles, as long as we've got not just, this is what Paul was querying earlier in the lesson, we can't just have a right angle. We need to have another angle in there as well. to help us figure out which one the O is. The O gets its place in relation to the reference angle. Okay, now here's a lovely multiple choice question. I do like a good multiple choice question. Which calculation would find the value of m? I want you to choose the correct option from this multiple choice question for finding the length of side m. For Teko's question, so what would happen if a was the denominator? Teko, we will deal with a question like that going forward. All you do is you would adjust the equation in relation to what you wanted to find. But we'll cover a question like that. We're going to do 6 lessons on solving lengths and angles. Okay, so we want to know what the unknown side is in terms of identifying the different sides. In this case, you have got the H and you want to know the A. That makes me think I'm dealing with cos. And I obviously am. And so I'd say m over 6 is the cos of 25. Now, there's nothing like, if I go m is 6 times. It's not that one. Okay, it's not that one. It's not. Oh, but cos of 25 times 6 is the same as 6 times the cos of 25. And so the correct option is A. Okay, cool. Oh, you guys have got this. I'm not going to do that one because we are fine on that. Okay, let's do a different. In fact, before we move on to this question, I want to ask the class, what is different? In this case, we're still dealing with a right-angled triangle, but what is different about this type of question compared to the ones we were doing earlier with SOHCAHTOA or trigonometry? So in this case, we're not finding an unknown side, we're finding an unknown angle. And when we find an unknown angle, we use what's called the inverse trig functions. Or we use, the way it would look is, it's still SOHCAHTOA, but instead of using on your calculator sine, you use the sine of -1 or the inverse sine function. And so, or the inverse cos function. Okay, now, if I give you an example of how to do this, the first thing is you label your sides. So this will be H. This will be O because it's opposite the angle you want to know, and that will be A. So what are we dealing with? Well, we've got 7, which is an O, and 10, which is an H. We must be dealing with the equation, the sine of X is equal to over H, or 7 over 10. So this is a trig equation we try to solve. And the way we do that is we apply the inverse trig function to both sides. And then that's how we get the X by itself, and we get this on that side. And what is X going to be? Well, I need to use my calculator for this. So I go shift sign, fraction button, 7 over 10. And what do I get? I get 44.4. And that tells me that the option over here is that. Now, that must be B. So this angle is 44.4. Now, just because I am curious, I want to know, I'm adding something to this question. Could you tell me what the value of the angle up here is, the big black dot? What is the value of the big black dot angle? Could you work that out, given that you've already done some of the working already? What is going to be the big black dot angle? What facts about triangles do you know? Well, you know every triangle adds up to 180. So I could just do this. To help me find that. So we'll get 180 minus 90 minus 44.4. What do we get? We get 45.6. Yep. And so this is what we call the complementary angle. So if this is the reference angle, that would be the complement to that. Okay, what if I said to you now, I want you to find me the area of this triangle? What would we need to find the area of this triangle? I'm kind of just making stuff up as I go, but it's a good question. I want to find the area of this triangle. What do I need to find in order to find the area? Well, don't we need the side over here? And we need the side over here. Because we need the two sides. So it seems to me like we need to figure out what the size of this adjacent side is. And if we could figure out what the side, that adjacent side was, we could then work out the area. So I want to put the challenge out. How do we work out what the length over here is? You could either use Pythagoras or you could use trigonometry. Both would work. Okay, both would work. So let's get the answer for what A is. I see a lot of you are using Pythagoras, in which case you would go 10 squared is equal to 7 squared plus, let's just say A squared. And then using Pythagoras, we would go 10 squared minus 7 squared equals that. So what is A going to be? So it looks like A is going to be 7.14. So that's the adjacent side. Now, to find the area, what's the area going to be of this triangle? Yeah, so we go half times by 7 times by 7.14. And it seems like based on what you're saying, you get 24.99 units squared. Okay, cool. So what in this topic, we're always going to be looking for either unknown sides, unknown angles, or areas. So is the height always the longest side? It's not. The height and the base are always formed at the right angle. So if you look at this, you could call this the base and you could call this the height, or you could do it the other way around, and you could, depends which way you're looking. The longest side in a right angle triangle is always the hypotenuse because it's opposite the biggest angle, right? So the height is not always the longest side. The height is just simply, a height is measured at a 90-degree angle to a base. Okay, so I hope that helps, Rafense. Let's do another one of these. So over to you guys. Can you find me the angle X in this right angle triangle? Cool. So that will be O, H, that will be A. So what do we have now? Well, we've got an O and an A, which makes me think that tan is involved. So the tan of x, so we can always write out my SOHCAHTOA if I want. So O and A are involved, and it's the O that's on top. So it's 10 over 8. And really, this is a trig equation. And to get x, I need the inverse tan of 10 over 8, which gives me 10 over 8. 51.34, which is C. Okay, now it is time for a preview of the next lesson. So if we look at what we did today, you were given simple triangles from grade 9 and 10. And then towards the second half of the lesson, we dealt with right angle triangles where you had to find unknown sides and angles and areas. Now, what is going to happen in the next lesson, and this is the grade 11 stuff, is how do we start to deal with non-right angle triangles and use trigonometry? So here's an example of a type of question we'll start talking about in the next lesson. And all I want to ask you is, before we finish tonight, what makes... So in this question, what they're asking is, what is the length of that side x there? And all they've given you in this question is they've given you 2 angles inside the triangle, and they've given you 1 side. And they've asked you to figure out what that length is. What makes this question quite tricky compared to the ones that we've been doing so far? Okay, Tebogo, let's go to you. Can we unmute Tebogo? Don't know if you can see Tebogo. Let me see if I can find it. Hey, Tebogo. What makes it? Yeah.
The only difference is that it's not a right angle triangle. So
yeah,
we have to use sine rules.
Yeah. So the problem is, that's exactly it, Tebogo. There is no right angle, which means you can't go and do this thing, which means you can't go and use SOHCAHTOA. So you need new tools. I mean, you could work out what this angle was, right? If you wanted to know what that angle was, you've got a tool for that. You could go 180 minus 48 minus 37, and that's great. But even if you knew that angle, it wouldn't help you because you're looking for that yellow side. And so what you need is you need more tools for solving for unknown sides and angles in non-right triangles. And so what I'm going to introduce you in the next lesson is something called the sine rule. And the sine rule lets you solve for angles and sides in non-right angle triangles when you're given certain pieces of information. Okay, and so that is a preview of the next lesson where we're going. But I'm going